I took out only the electronic boards for measuring for the moment, but I will not put them into the cases yet, because I will have to make an operation. I will have to cut that line and insert and move this module here a little bit, as wide as this from here to here, and these two ears or wings of this board will have glue on them and will stick from beneath. So we'll stick this module here and the rest there, and this will fit between this module here and the rest. This little module that I'm building right now, and this is the button. I've already tested it with a continuity device that I have. This guy here that is staying behind here. You see, like, trusty continuity meter. And I checked the pins, and also what is very important, I made actually I made this circuit here. I've kind of mirrored that 555 circuit, integrated circuit there. This square is that large pad that I have there, another pad there. So I have that pad there and this large pad here. This is the resistor that it should be on this pin there. And I've also added, and pretty much this is all that I need. Only this part here. So the resistor is linked to this pin and to the middle of this button, and then a link to the positive here from this pin to that. Let me actually show you how it's looking. You see, it's having two sides, the pins on two sides, and on the other pad for the third pin will go to 7474 on its output on pin 5, and there's this one here, I think, yeah, 5, and from this I will have to drag a wire to there, pretty much, and I only need this part. But I was thinking, because I have two sides button, I can actually put some LEDs, and you can see them here. This LED is also 5mm, which is a pain in my ass. I don't really like them, and also a resistor for each of them. And this link from the middle will go to the positive somewhere there. I erased and corrected this thing a lot. Actually, it can go directly on this pad as well here, going. So the positive is going here, and when it's clicked one way, it will light up this LED with its resistor here, and this is going to negative because this pad here is the negative. I hope, yeah, it is. And when it's clicked the other way, it will light up this LED through this resistor here, going to the ground. Pretty much, I will have a double working option. One, it will do the real task that I really need to do it, and then a secondary task, lighting up some LEDs for each mode, for continuous mode and for stepping mode. That it will be, that from this this is the stepping mode, and this is the continuous mode, from here to here and from here to here. I've also draw a tiny bit of a switch symbol here, and this is how it's looking inside of this switch. When you press one click, it will switch between the middle. Actually, I should put like this. So between the middle and this, and here as well on this side, on the right side. And when you click it again, it will switch to the left side and also to the left side. So yep, it will look good. It will be awesome. We will see next time when I will actually build it and hopefully mount it there. Yes, excuse my non-cleanliness that I have, the misery, and how it's looking here. These are burned marks. The paper is getting burned from working on it, and it's not from now, but for a long time ago. So what I did right now, and it is in process of making it. I've let me get this. So originally I was thinking, I thought to put here a resistor. Let me point actually with my knife. So to put here a resistor and here another resistor. So two resistors, and this is the LED, this is the other LED. But then I realized I can link from the positive here. This pin is linked to the positive, and from this pin from the positive, link a resistor to the middle. And whenever I will switch the button, it will switch between this LED and that LED through that resistor. The problem is that this green LED is very not that good with very low current. So it needs a little bit of kick in the ass and a little bit more current than usual. So here I use a 470 ohms specifically to drive bright enough this green LED. But for this yellow LED that I have here, this 470 is a bit too low. It needs somewhere around 1 kilo, somewhere. Now with 470 is a bit too bright than I am usually used to drive this all types of LEDs. I'm not speaking about the new types of LEDs, but these all types of LEDs, they have their own rules pretty much, and they are highly dependent of the current, and that's why we are adding those resistors specifically for them. And pretty much this is it about this part in the process, and it's looking good. It's looking good. I managed to bend that leg, that positive leg of the green LED, and you can see it as well here. It's underneath there, and not touch anything else. And this one, this yellow one, is a bit of a problem because it is also in this left side as the green, and I have to circle around, but it is fitting good enough here. You see, it is already. Another problem that I have, and I will have to think hard. This pin of the LED, of the yellow LED, is linked directly to the negative rail, and here on this pad, I have the positive rail, and these are dangerous, very dangerous, close together, near each other, and I'll have to think. For the moment, the solution is just to trust in this distance that it will hold as it is, and hopefully no funny business, no short between those two. Very extremely close together, near each other. Yeah, hopefully it will be good enough in the end. This is it for this part. All right, I managed to make the operation here. I cut with the scissors only this part. I introduced this module here with its resistance. I hope you can see all the details, what is going on. There is a jungle. Here is a jungle of wires, I'm telling you. You see this? This and that, and the other one here. And this one that is floating, this is actually the signal that it will go to the output pin, somewhere there from 7474. This is the LED, the green LED that is catched there to the negative, and also to the positive, and on the middle there is the resistor, and this wire from the capacitor goes there, and another wire is going to that pin there, and it's a mess. And now, why I'm making this movie? I'm making this movie for this particular LED that I have here, because as you can see, it's impossible. It is absolutely impossible to put this LED there and not make a short, because here is the positive wire that is going to that resistor, and it is occupying entire space there. And there is another wire, this guy here, and another wire that will come. I didn't put this yet. Somewhere there, pin 3, I think it was. And this guy is absolutely impossible to put it there. I considered not to put it at all, but then I stayed and thought about it, and I said I must find a solution. And it was having already the pins. What I did, I bent the pins, and I've used this PP, polypropylene plastic, type of plastic, and I don't have much there, but I have a ton in another part of the room in my storage and box. I have a storage box, and I 3D printed manually, of course. I think you can see the leg through the, yeah, you can see it. And you see, and I 3D printed it with my trusty iron, soldering iron there, bit by bit, until I made this very custom shape that is protecting both pins of this LED. And actually, it didn't stick at all from this plastic. It didn't stick at all. My PP plastic, polypropylene, is not compatible with this type of plastic. They are like two magnets. They don't stick. Whatever you do, it's like oil and water, exactly like that. Is after it's getting hard, this plastic, it will just jump from where you put it. So right now it is stick to itself and surrounding those pins, and that's it. Is like a case for the pins, only for the pins, and this is it. This is how I will mount it there. I hope I made my calculations right, because I didn't test it yet, but the idea is that it will go there, yeah, something like that, and also on the same side. And from here I will drag a wire to the negative pad here, which is a mess and full of wires and pins. Holy shit, what is there? Is this resistor here, the black one? Actually it's a green, darker green resistor here with very thick leg. This capacitor, this transistor, this the LED, this wire here, you can barely see it, but it is there. This is actually providing the negative rail. And another wire, that is this wire here, going to this pad to continue the negative rail. So it's having a ton of pins there already. And I'll add another one from this LED here. Holy shit. Yeah, this was a hell. Yeah, this was a mistake not considering it in the very beginning when I started the project. But well, I'm doing it now. So it's exactly how I said I will do it. I glued those ears beneath it. Hopefully I can turn it around. See, yeah, you see how it's glued there, and it weakened a little bit the entire board, but I have a new module there. All right, voila. I made it. I made only the button part, but not the other connections from the flip-flop there. But it is working as intended. That LED is overdrived and a little bit too much current on it. Look how his brother is there and how bright it is here. This is actually a new LED. This is old, but it looks more bright on the camera than it is in reality. But in reality, it's also quite bright. And the green LED is just okay. And yeah, probably I should have used a little bit higher resistor there. But yeah, I was just I made the test right now to see if everything is behaving all right, and it is 216 there, and absolutely gorgeous. And let me close it for a little bit. You see this wire here, it's impossible. You see that yellow LED, how it's having that mesh of plastic, and I'm very happy nothing is shortening, nothing is in short, because it was a mess behind that LED, that yellow LED. This is his wire to the ground, and I had a little bit of a problem there to actually get there with the iron, with the soldering iron, but I managed to make it work. This wire is actually it will be linked to another flip-flop, probably from the same IC. I am crazy, and crazy enough, and I will think about using the same chip for the second flip-flop to actually use it. Hopefully, I really hope. I think I will have to cut another piece here and actually insert a little bit more of the circuit that is needed there, and then drag the wires. But here was hell. Here was a hell of wires. I had so many, and it is still looking hell-ish. It's very, I don't know, concentrated, but it is working. That's the good thing. Come on, it fell off like that, and it stopped, and this is working. Absolutely brilliant. I love it. And slowly but surely we will add this new functionality to this entire board. Holy shit! It was hard. Now it's set to 4 there, and now it's to 8, and it's going 7, and on 8 it will reset. Pretty good. Oh, crazy. I should have considered from the start, from the beginning, adding this, but I didn't. I actually made that circuit that I showed with this add-on that I'm making right now with continuous and stepping. I've added it yesterday, actually, before I make it. I put it here, and it was after I finished the entire project here, sub project actually, and then I thought I had an older version of that stepping method, but it was very old and very shitty, and I had to adapt that mentality, that idea here, and I couldn't adapt it here actually, and I had to invent another way of stepping using a flip-flop. The others in the other circuit, the older circuit, I don't remember what I did there. Yeah, but it was weird. It was doing the thing, but it was very weird. And here it's good enough with this button and also that flip-flop. It will work as I'm thinking to add SMDs, but I don't want to cheat. Well, we will see. I don't really care. But what I care actually is to repurpose all these old components that I have. Of course, I cannot repurpose everything, but a good majority of them are repurposed, and I'm very happy about it that I managed to do it. Yeah, this is it for this part, and I hope I will actually make it a step on a press of the button. I will have to really think hard where to put that button, and it's a challenge. But I really like how it went with this button, with this switching between modes here. Very good. I like it. I hope you like it too. Leave a like if you like it. All right. Hello again. How can I show you everything? I will use my left hand. So what you are seeing here is a NOT gate made from discrete components, but also from SMD components, and also from scrapped SMD components, because I did desolder all 3 of them from some boards somewhere, sometime. This is the circuit. Actually, is a transistor with a 1 kilo resistor on its collector. I should note. Yeah, damn it. Yeah, I just marked here on the circuit diagram. This is the collector. 1 kilo on its collector. 10 kilo on the base of the transistor, and the emitter is linked to the ground. Here is plus 5 volts through this 1K. And this is the out pin, if you want, and this is the input pin, if you want. And you must have a positive and a negative rail, and an input and an output. So 4 pins in total, as you can see here. 1, 2, 3, and 4. Okay, this is also not copper and it's sticky. And pretty much this is what you are seeing here is exactly as you see it here. Draw. This is the transistor. These are its markings: collector, base, and emitter. And this is the drawing. What I did there. This is the transistor with its middle pin here and the 2 other pins here and here. This pin is staying in air, is not soldered by anything, and is linked to a wire there to the ground. And this pin is soldered by this resistor here. The other side of the resistor is linked a wire to that signify the input of the device. This is another resistor here that is linked to this pin here of the transistor. This very tiny band I could solder there. And from the other side is another wire. And here are 3 connections actually: this resistor band, this pin of the transistor, and the wire that is going to the output. So this is what you are seeing here exactly. So I made some pictures about the progress, how to actually make this small SMD device, not gate in this case. And I was playing around and, until I find a good solution. And this is the first, what you are seeing right now is the first idea, but I didn't like it. And also like this here, I was thinking to make it like this until here. This is the actual final mode. Here is the resistor. Actually, let me draw it on top of it. This is the one resistor. This is the second resistor here. And with another color, let's see, with green, right? This is the leg of the transistor. This is the other leg of the transistor. And here is the other leg of the transistor. And this is the actual transistor here. Let's see, like this. This is the transistor here. And of course, it's having a little bit of depth there. It's from a side, but it is soldered here from this resistor pad here, and this is the other resistor pad on the other side. So pretty much that's the idea. Here is again in another view, and here I hold it in on my finger, but yeah, it's good enough, and you can see it, how small it is, and also from the other side. I don't know how well you can understand what's happening from the other side, but it's small. It's very, very small and very tricky, very hard to work with it, very hard. And I believe this is it. These are other views of it. Yeah, this is it. Actually, I will mount it at 90 degrees like this, turned, and I will turn this as well because you see it's having different wires on it, and that's for a very good reason. First, for strengthening the device, not to move itself by itself or by mistake. So this was a bit more thick wires are ensuring a little bit of strengthening, pretty much. This and this. Only this guy here, which is the output here, this guy here. Only this guy is very thin because it's linked there and it's very extremely fragile area, very, very fragile when soldering. And my soldering iron is not having the thinnest or smallest point. You know, it's quite thick for this area to solder. And yeah, I did it. I managed to make it, but I don't have the proper devices, you know, to work with. So why is having this shape and form? Because it will fit right here. If I can actually put it there. No. Let me use something that is not magnetic. And it's that capacitor there that is not letting me. So this is how it will stay there. And this long wire, it will go to the positive there. And this very thin wire, it will go to pin 11, which is right there. But I've also marked here what is what. So here, this wire, as you can see, it will go to pin 3. So pin 3 is somewhere there. So 1, 2, 3 there. This is very nasty because my iron cannot reach very good, but it can reach a little bit, and it's very close to this. I have a lot of components here that they don't let my iron to enter there and do its job, and I kind of working blindly. I kind of feel by touch, by pressing. I feel that is making contact, but I not really see with my eyes what is going on there. And then I'm testing it with the tweezer. I'm dragging the wire if it's soldered, and that's how I manage in this very tight spots that I have. This let me continue. Also here, this wire, the output, it must have a 1 kilo resistor here from pin 11. So this is the pin 11 here. This bent wire that you see on the button here. This is the pin 11, and from here I will have to drag a resistor, also a SMD probably, most probably, and then link this very thin wire to that resistor there. When I decided to make this NOT gate, I literally thought is impossible because to make it on this circuit that I already have here, this was very, very hard because I have a lot of wires. This module here that you see with the 2 LEDs and the button and that green resistor that you can see there. I had to cut here, and the length of the other wires that were previously linked to everything, well, I had to change some of them. This one, the brown wire that you see, I made an extension here, and it's doing okay right now. It's good enough, but the other wires I changed them completely, and that was very hard because I had a lot of wires, probably like 6 or 7 wires. The positive, this data wires. Here a lot of logic wires that I had to link. The negative as well, that you can barely see it, but is there. This is it. This is the wire here. You see it? And yeah, I had to pay extra mega attention to the wiring, and I kind of remembered everything. I tested it and it worked, but it was very hard because of the multitude of wires. But when I came here, this segment of the circuit, this area of the circuit, first of all, I had to really think hard how to mount the button. Where to allow its space to be, and I thought it's impossible to mount anything. And right now is not correct. Let me take out this NOT gate from here. Come on, motherfucker, like that. And good. So I thought it's impossible to mount it anywhere here in this area. Then I really thought hard, and I said, well, let's try to see if I can actually mount it. And I mount this very ultra thick wire for security. It's not glued. It is not glued, it is not screwed, is floating, is literally floating, but is only kept in position and is not moving away by this very thick wire that I soldered here laterally, and another wire that is going directly to the negative pad that I have here. Also, this is not correct, because in my diagram I is not going to the negative pad directly, is going through a 500 ohms resistors. As you can see here in the test that I made previously, I have this 1 kilo in parallel, which means a 500 ohm to the negative rail. So I will have to change this wire and put a resistor here, hopefully with thicker leads, to secure, to offer a bit of strengthening to the entire device, to the button itself, to stay put, not to move very easily. So, but this is temporary here, just to place it, to have it in place. And now the NOT gate, that is an important part, is I said, I literally said is impossible, is absolutely impossible. But the position and the location and the board that I have here, unbelievable hard, unbelievable hard. I had to think to imagine every possible angle, every possible route that I can. And then I found this good enough, good enough solution right here that I have. You see it? And it's good enough. And it will link in air with everything, with some parts, not totally in air, but it is kind of in air a little bit. And it's looking like it will be a possibility that I can mount it. And I am amazed as you are right now, because it's terrible. It's extremely hard to make it and actually function. And then after I will mount this NOT gate here, let me put it back again. Sorry, there. After I will solder everything, I will also have to drag from pin 9, which is here. Let me point with this guy here. So this here is the pin 9. From pin 9, a resistor and an LED to the ground. And that's it. And I think I will have to add a capacitor here from pin 9 to the positive rail there. But I'm not sure if you can actually see it, but it is a hole there. And also another hole here, exactly where I'm pointing. You see it? It's a hole. I punched the cardboard with my needle, and I put a wire, the link wire that is going to these 2 pins. As you can see it probably here, this wire here is a link wire between 2 pins, like that. But I put it under the board. Let's see if I can turn it on the other side without breaking anything important. It's very fragile. Yeah, I can. So there is the link on the other side of the board. And I was thinking to put on this side as well, but I left it there for the moment, because I thought I cannot reach with my iron there on the pin 3 to link the... Where is my NOT gate? There it is. Okay. So, come on. Yeah, no. Good. So, this is the progress so far. I hope it will work, because the amount of work that I did for the button and for the NOT gate, the amount of work that I put into them was and still is phenomenal hard. Very, very hard. I'm stepping one thing at a time. I'm doing one thing at a time, and very, 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 very slowly, because I don't want to screw it up. I don't want to link and also break this extremely fragile soldered components that I have there. I was thinking also to put some plastic all around it, and probably I will, but I'm not sure yet. I'm not very sure yet. But if I will have problems, I will incapacitate it into plastic, encase it in plastic, mold it in plastic. But we will see. Until then, I will leave it as it is. So I wonder how small and how very hard to work with it is. All right, this definitely deserves a praising. This is a miracle circuit, what I built here. I was 50% in doubt it will work, but voila, it is working. It right now is in one mode, in the step mode, in this moment. Before anything, this is the actual way I built it. I took it out from its case, and because I had to work on it, so I'm filming it as it is right now, and then I will film it when it will be in the case there. So pretty much right now, like I said, it is in the step mode. When I'm pressing this button, is performing the 8 is good enough. It's pretty much like the testing breadboard that I did there. It was a hell. I'm not sure how well you can see everything. Let me actually show you a little bit. This is a resistor, SMD resistor, 10 kilo, and this is a green LED. Actually, let me switch it to automatic mode, and you see, these 2 LEDs should be synchronous, but because it's a NOT gate there, is actually inversed. But it also is about the timing, pretty much. Let's see, now it's synchronous now. I think sometimes it can be synchronous. Let me actually restart it from plug it. Yep, it is synchronous. So so these 2 LEDs are the 2. What I did here, I used the 2 flip-flops from the same chip. it was crazy. I tell you, it was crazy because, and it's still crazy. All this circuit, it's a miracle. I could make it. It's a miracle. I could make it working. This was not part of the design. This secondary stepping circuit, and I had to include it somehow. And it is working. When I'm switching from here, I had a lot of problems, especially on the negative pad that I have there. There are a lot of pins and very thin wires, and they are probably I had some errors from these two LEDs. Some of them didn't work. While I was working here and I was concentrating on this problem that is very, very problematic, this little thing, not gate that I made here, and I managed to wire everything. I hope you can see. I hope I will not make a short. Here is a resistor. Can you see it? Is staying like this. It's not staying normally like that, but it's staying vertically, you know. And then the wire, very thin wire. It's, I guess that was the output. Let me look on the little paper I have here. Yeah, I think like this I mounted it. Yeah, exactly like this. So this was the output wire, and through 1 kilo here to pin 11, and that's what is there. Is a resistor. I'm sorry, I cannot actually. I can zoom in. So there it is. That's the resistor. How much? 1 kilo. Yes, you can actually see it. 102. And here is the transistor from here to here that is staying on top of two resistors there. 470 ohms. That's for the button instead of 500 ohms. And there, where are you? There is a disaster. It happened. This disaster. All those pins that all those connections. It's I had a lot of problems there to actually so make them stay there, not snap out from the soldering. Very, very tricky. Very. And also this LED is its positive leg got out from its soldering there. Probably I was moving it and it got loose. But I'm very, very happy and also amazed that this is actually working pretty good. Pretty good. It's fucking crazy. Trust me, it's crazy. So here it is. I'm stepping it. It's like I'm creating a step of whatever count I'm setting here. Let's count to 16 and stepping it to 16. You see the last LED is lit, and when it's finished, when it is getting to the reset pin, is stopping there, staying nice. If I'm switching from here, is continuously, you know. Also interesting, very interesting. I've observed something. I can do this, and then if I'm quickly press it again, it will stop. Let's see. You see? But it is listening to my impulse when it's stopped, but not when it's running. You know, I can. Sometimes I can catch it, okay, but not all the time for some reason. Let's see if it's working synchronously again. No, it unbalanced itself. This is actually, yeah, switching correctly, but that is not switching correctly. But doesn't matter. That doesn't matter. It's only the flip flops, especially the white one, is the last LED, which is absolutely non-important. Really, is not important. Is only to tell me that is switch something, that something is switching. Other than that, the entire functionality is there, and absolutely, oh fucking K. All right. And I am amazed. Of course, this SMD jewelry that I made there helped my ass and my circuit, and I will never do it again because it's so hard. And also this guy here is unbelievable, and all the wiring and all the. I had to mega concentrate on this. Like it took me like 3 days, I think, 2 or 3 days only to make this NOT gate, to catch it on all of those, to make all of those connections. And also this module wasn't easy at all. It looks deceptively easy, but it's not. It's very, very tricky. It was tricky because of all the wiring and everything. But absolutely, I am amazed that is working. Trust me, and it's looking pretty cool. All the lights blipping and everything is doing the thing. All right, I will put it in the case, and we'll see you later. Now in its box, working fine as usual. Is I left it set to 16 there, and absolutely gorgeous, absolutely fine. And the stepping mode. Excellent. Yeah, right now it's in the box as it was before, only with a slight upgrade there that was absolutely terrifying to work at, and it's a miracle that is working right now because all the wiring and all the logic I had to put in there, it's crazy. It was crazy. Still is. It's still crazy. So yes, thank you very much. I hope you like it, and yeah, bye bye until the next time.